probably heard of the cloud.
Yeah.
You put photos on the cloud, your emails are on websites. And I think what's important to realize is that everything that's sort of, out there in the cloud really lives on computers like your laptop or your cell phone, but they're placed in these large sort of warehouse-like buildings called data centers.
Professor Jake Searcy, thank you for coming here today. Would you like to introduce yourself a little bit, talk about some of your research or your academic interests?
Sure. So my name is Jake Searcy. I'm an assistant professor of data science in our data science department. My lab trains machine learning and uses AI, and our goal is to mainly use it for positive social impact. And so we work in health, we work in climate, we work in sort of social justice areas, trying to make these tools sort of good for society.
Awesome. I'm just going to start off with a very, very simple question. Could you explain to us what exactly data centers are and what purpose they serve?
Yeah, it's a good question, and I think you've probably heard of the cloud.
Yeah.
You put photos on the cloud, your emails are on websites, and I think what's important to realize is that everything that's sort of out there in the cloud really lives on computers like your laptop or your cell phone, but they're placed in these large sort of warehouse-like buildings called data centers that house large numbers of computers, large numbers of hard drives, and sometimes now with AI, very specialized compute devices like GPUs that do high performance computing or lots of computing at once.
Interesting. So these aren't clouds, these are physical facilities that take up physical space in the real world.
Yeah, the cloud sort of exists in our nebulous interweb, but everything lives in a real solid location in a warehouse somewhere on this planet.
Interesting. So while data centers are now often associated with AI, data centers actually run all kinds of operations, like cloud computing to the internet. Could you walk us through the demands of these different, the demands and requirements of these different operations, and explain what makes AI data centers different?
Yeah, so I think most data centers you can kind of think of is, like your phone or your laptop scaled up, millions or billions of times. So they all need some power to keep them running. They generally perform many actions like communication. So they all have usually high-speed internet connections to let you talk to them from anywhere in the world. And they all have what we call compute infrastructure. So these would be, CPUs or an AI GPUs. And the second part of this question,
I was just going to ask you what makes AI data centers different from those ones?
So what's sort of new in recent days is AI, particularly large language models, particularly companies like OpenAI and ChatGPT and Google are starting to integrate services that are sort of AI-based. So if you type into Google, you do a search, you might see an AI summary. If you ask a question on ChatGPT, it might call an AI model. And this is sort of different. So when you used to type into a Google search, it would sort of look through a database and do some algorithms. And I think one of the main differences is these AI models take much more compute. So they take, use billions of trillions of weights, is what we'd call them, and essentially there's numbers, and they sort of simulate what we often think of as some kind of understanding of language. And maybe the drawback of this is it can take a little bit of time because you have to do all this computing, and also can take a lot of power.
Right.
And sort of able to use these AI tools, data centers have started to adapt infrastructure that allow them to use both high-powered, we call them GPUs or graphical processing units, which are these specialized chips which are really good at essentially multiplying lots of numbers really fast together, and at the sort of most basic level of an AI system, that's one of its key components. And so we're seeing more and more sort of high-powered GPU-based clusters, which also mean high energy use in most cases.
Do you know why it is exactly that AI data centers take up more energy? Is it because of the graphics processing units, or is there a particular reason for why they take up so much energy?
Yeah, I mean, I think it's, if you kind of think about a very simple like operation, if you were going to like look something up yourself, you know, you might kind of scroll down and you might find, like alphabetically, look up a name, find it. I feel like a lot of sort of non-AI based algorithms sort of use these sort of highly optimized, relatively simple, but not very intelligent kind of methodologies for pulling information. So when I type in a website, will be a server somewhere that'll say, okay, this website means go to this data center and retrieve this information. And you don't need any AI to do that. When you start using AI does something sort of akin to simulating intelligence, so artificial intelligence. We think of a computer that has some of the aspects of human intelligence. And this takes not a simple operation, but actually a very large, very complicated operation that takes, you know, we call them weights that have been trained, and so it's not immediately clear even to the people who wrote it, all the operations it's doing, but it executes many, many, many operations on many, many, many different CPUs or computations at the same time, which just takes a lot more work as well.
Right.
That's why when you type in search to Google now, it'll say like waiting, so it's doing all that computation, and then it'll start sort of appearing one letter at a time until it fills out the application. And this enables a lot of new creative thinking, but the downside is more compute and more power usage.
Right. Okay, well that kind of brings me to my second question here. So there are many different steps involved in the development process of AI models, right? Like, you know, pre-training and you know, other steps. Could you explain these different steps of the development process and what role data centers play in each of these steps?
Yeah, so I think data centers are probably integral to all the steps. And so a normal training process for an AI model is you would sort of define the architecture of the model, and if you look at the name ChatGPT, GPT stands for Generative Pre-trained Transformer. So this transformer is just the name of sort of the algorithms used to build the AI model. Pre-trained means they take this model and they feed it information, you know, usually terabytes and terabytes of text and images, to sort of let it learn from the data it's given how patterns emerge in language, how those patterns relate to images. And what you get after sort of pre-training is something that sort of feels like what we're familiar with when you type into something into ChatGPT. But its quality, its responses are a little bit strange. They might not be very accurate. They might say things you really don't want them to say.
It's kind of unpolished.
Very unpolished, yeah. So the next step would be, you know, the chat part. Generally involves what we call human or reinforcement learning with human feedback. People have sort of put the thumbs up, this is good, thumbs down, this is bad. And so in there, a data center is, you know, taking the data, having the model respond. It's hosting the website people are using, and when you sort of click, you know, the up and down arrows, that feedback is going to a database. This is also going to be at a data center, and then eventually all of this will get folded into a retraining of the model to sort of make it perform like you would like it to. So you don't want it to say derogatory things. You say thumbs down enough times and the behavior goes away. You want it to be accurate. You go thumbs down anything that's inaccurate, and eventually it sort of becomes more of the polished
shape
tools
it
we look
into
at.
the model you want. Interesting. Which of these steps would you say takes up the most energy?
So it's interesting. We normally divide this into sort of inference and training. So inference is the word that we would use to say when it's being run. So you've trained it.
Inference
exists.
is the finished model. Okay.
And you're just sort of talking to it back and forth. So for a really long time, I think the training is what you think of. It takes the most compute. It takes lots and lots of data. It takes a very long time. It can cost tens of millions of dollars. So that's a very energy-heavy process. But I think as we've sort of shifted from these being kind of like a novelty and like a useful research tool into something that is just part of all kinds of products all the time. We're getting every single time there's a call to this model, or it's running a inference responding to a chat. That's now not just happening, a couple of times. It's happening from people all over the world all the time.
Yeah, like everybody pretty much.
Yeah, constantly. And so I think that that kind of balance has shifted a little bit. So it takes a lot to train, but then it also takes a lot to sort of keep running all the time.
Interesting. So as more and more people use these AI models, then the energy consumption of the inference stages.
Yeah. Every chat takes a little bit of power.
Okay. Interesting. Energy efficiency seems to play a key role when it comes to the environmental impacts of these data centers. Up until around 2019, the energy consumption of data centers had remained relatively stable at around 200 terawatts per hour. Since then, though, the energy demands of data centers have increased, largely due to AI workloads. Could you explain why energy efficiency has become less stable in recent years and how AI workloads contribute to this issue?
Yeah, I think there's been a long time trend, which is maybe starting to flatten out, of, we say, bigger models are better. So, we'd say more parameters, more data. And I think the downside of that is sort of the more parameters and more data, sort of the more compute you need to do. And sort of the more compute you need to do, the more power it takes. And so I think there's a very sort of clean relationship. If you get sort of bigger, more powerful models, they work better, so they become more popular, but they also require more energy to run.
Right.
And so I think as we see bigger and bigger models, we see better and better models, we see more and more adoption, that all sort of points to needing more data centers, which need more power.
Okay. Interesting. So then that would therefore kind of destabilize the energy efficiency.
Yeah, and I think, before AI, we just weren't using these tools. They didn't exist. There was no demand for them.
Right.
I think now that we have a lot of a demand for them, there's a lot of new need for this infrastructure to sort of meet the demand that's being placed on them.
Right. Okay. There's been a lot of attention brought to the water consumption of data centers. Could you explain what role the water plays in these data centers?
Yeah, and I think, it probably varies the details from data center to data center, but like primarily when we talk about power, the power leads to heat. I don't know if you've ever watched too many videos on your phone, it starts to heat up.
Right.
So if you imagine thousands and thousands of computers all putting out a lot of heat at the same time, you don't want the equipment to melt. You want it to be running at a reasonable temperature where everything is safe and working well. And so that means the heat needs to go somewhere, and that often means cooling. And so water is probably primarily used in either evaporative cooling or sort of direct transport of all of the heat in these data centers. So as they're stored in what we call racks, so you see many computers. Racks will often have chillers, which are essentially like little air conditioning units. They're all sort of water powered, and a lot of that water, some of the water gets discharged back into the aquifer. A lot of it gets evaporated to sort of evaporatively cool the amount of energy going into the data center.
And there are other forms of cooling too. Could you go over some of those?
Yeah, so I think, the details all matter. I'm not an expert in all the ways we cool data centers. You can kind of think of the simplest way, what your phone or your laptop uses is just air cooling. So air from the environment sort of goes in, it's cooler, just fans. That's often insufficient for a data center because you have lots and lots of these systems really close together. They're in sort of an enclosed room often. And so the next best thing is to then bring in something like water that can help sort of absorb that heat and transport out and then cool evaporatively. I think one of the newer technologies that people are getting excited about is this thing called submersion cooling. So instead of sort of cooling all the air around these big data centers, you very specifically cool the chips in usually a liquid that is not conductive. I don't think, to my knowledge, this is really widespread deployed yet, and so I think there are sort of new, maybe advances in technology. People are interested in bringing cooling sort of more efficiently, so you're cooling exactly what you need and not necessarily like either the whole building. but I think this is probably a ways out, and it might have its own
Right.
consequences.
Yeah, of course. So do you think we're possibly heading in a direction where we're going to start exploring other forms of cooling for these data centers?
I think there are a couple of competing demands. So, I said bigger models are usually better, is what we've seen. So it often leads to sort of more powerful processors. So, I've said GPUs, but there are many kinds of GPUs. Some are very expensive. Some require what we call on-chip liquid cooling, means there needs to be liquid moving through the chip itself. Some don't need that, and so there's a variety of these, but there's been a push in terms of performance, so getting better AI models to make chips that are much more powerful.
Right.
And much more powerful chips produce much more heat, so the amount of sort of compute you can do on a chip is also proportional to how much heat you can take out of it.
Okay.
So from a performance perspective, there's a lot of how can we innovate in the cooling to make the chips more powerful, and I think also from a cost and environmental perspective, there's a lot of interest in how can we make the algorithms themselves take less energy, so they take less power, require less cooling.
Right. So typically the more powerful these models are, the more heat that there is, and then the more work you need to put into decreasing that heat with cooling options. Okay, interesting. The production of AI chips, such as GPUs, graphics processing units, also raise environmental concerns. Could you talk a little bit about the different computer chips that are used and why they are so important to the widespread development and deployment of AI?
Yeah, so I think this has been, a GPU graphic processing unit. When I was young, they were primarily used for video games.
Right.
Which is an interesting switch now being a primary driver of AI. But what made them sort of unique and special based on your CPU is sort of specificity. So the CPU that's in your phone or your computer usually can do a lot of things pretty good.
Right.
GPUs do very specific things extremely well. Okay. So they're not as flexible, they're harder to program with, but they do certain things like multiply large numbers together very, very effectively, very, very fast, can be tens, even sometimes hundreds of times faster on a GPU than on a CPU, but they don't work for every workload.
Okay.
And so almost all devices have a CPU that do the more general task, and if you need something very specific like an AI model, they can be accelerated. A lot of times we refer to just accelerators in general, which would include GPUs and TPUs and other kinds of products. And so without these kind of accelerators, the amount of time it would take to, say, get a response from a chat wouldn't be, a couple of seconds. It could it could be tens of minutes even.
Yeah. And so what do a lot of these AI models like ChatGPT, for example, do they use just a GPU or do they use multiple different kinds of chips?
So I think it probably depends a little bit on how it's being used and who's using it and when. When you're training a model, it almost is all living on a GPU. I would say almost all models have some kind of accelerator nowadays. So at most data centers, they'll have these customized hardware that you probably wouldn't find in your laptop. Oftentimes those are GPUs. I think there's something called the tensor processing unit that Google uses, which is kind of a similar device. They're all variations of the theme of how do I do the specific computations that are really common in AI models as fast as possible.
Right. Interesting. Okay. Before we wrap up, I have one more question to ask you. Given the recent surge in the energy demands of data centers, data center operators have been exploring alternative power options such as nuclear technologies or hydrogen fuel cells. What would you say are the pros and cons of these alternative power options, and what impact would they have on the environment?
I think it's a good question. I think with all these different options, I think it's important to think about the location almost as much as the actual technology itself. In Oregon, we have an awful lot of data centers up along Columbia because we have a lot of hydropower. Hydropower is great from a CO2 emission standpoint. It's very bad from a salmon and wildlife on the river kind of perspective. So there are, across all of these different domains, usually trade-offs.
Right.
If you have nuclear power, then you also have to put the nuclear waste somewhere. hydrogen fuel cells, you still have to actually make the hydrogen that requires power. That often means hydropower as well. Just makes it a little bit easier to move around. There's no, I think, real sort of magic solution. I think there's certainly energy that's clearer than, say, burning coal, but there are always going to be some environmental trade-offs that you would not have to make if you just didn't use the power in the first place.
So do you think there's any option that is the most promising environmentally wise? Or do you think they all kind of have their pros and cons and it's more complicated than that?
I suspect that it's always going to be the right solution for the right place, and not all solutions are going to be right for all places. You know, a data center using all the water in Arizona feels very different than like a data center using water on the Columbia. They'll have very different environmental concerns. I think that's true with power. I mean, solar power has very different properties in the Pacific Northwest than it does in Arizona. You know, I think for me, the biggest opportunities are probably how do we take these really sort of large, high-powered AI models and find the sort of next step in that technology that doesn't require major computing centers, major GPUs.
Right.
You know, if you kind of think, is an analogy, the amount of watts we as a human being use at any given time is, you know, a little less than 100. A single GPU chip, of which a large AI model might take several to run at the same time, can use, you know, 200 or 300 watts a single chip.
Right.
So like, you know, not artificial intelligence works really well at lower powers. And so I think in terms of my dreams and hopes for AI, the most promising areas are how do we take those algorithms and make them more power efficient? Less necessarily than how do we produce more and more and more power.
So how can we progress while still staying sustainable?
Yeah.
Interesting. Well, Professor Jake Searcy, thank you for your time today.
Yeah, my pleasure. Thanks for having me.
Thank you.